going to do is begin with 0, and I'm going to show you this. I'm going to walk you through it. You begin with 0 at the early start of activity A. Now look at activity A. There is divergence, right? It's diverging into other activities. It's connected to other activities. So activity A diverges or splits off into the other activities, and then everything converges onto activity H. So looking at this, you already know that A and H are part of the critical path. They have to be. Okay, they're attached to everything else. All right, well, with that being said, kind of keep that in mind, we'll go through and I'll just show you the answer. All right, and how I got the answer. Start with 0. This is the earliest that you can start, plus the duration of 1. Okay, that means the earliest you can finish activity A is 1. All right, because it takes 1 month. Now, the best bet is to take that one and just do the individual paths like you've written them down on the paper. Only focus on A, B, F, and H, or A, D, G, and H. Now, what makes this so difficult, and why I wanted to do this, is that there's definitely going to be a different strategy here than the one we covered in class. It was very straightforward. There wasn't any convergence at the end. So it makes it a bit difficult. Now, you carry that 1 up to B. Okay, that's the earliest that B can begin, plus its duration of 8, ends at 9. Okay, what's the earliest you can start at? 9 months, plus 2 gives you 11. But my question to you is, why do I stop here? Why don't I just carry that 11? Because you're looking at the answer. Why don't I just carry that 11 directly to H? Well, go ahead and just cat it. Why don't I carry that 11 right over there? How come? How come? Yep. Why don't I just carry that 11? Why, there you go. And Judy, I like what you put. She said, I don't know if there's a critical path yet. Exactly. Okay, because it's common. Exactly, because it's attached to every other activity. And we haven't done the math yet on the other paths. They all use H. Exactly. So whenever you see convergence into one ending activity, you're going to want to make sure that you stop and do the math someplace on the other ones to evaluate the other paths. Exactly. Okay, so let's do that because you're absolutely right. It's not the critical path, but we may not know that yet until we do all the rest of the addition, but in this case, you're absolutely right. All right, so we've got the earliest that you can finish activity A diverging into D, so you carry the 1. Plus 4 gives you 5, carry the 5, plus 7 gives you 12, and stop. For the exact same reason. All right, we're going to come down here. We're going to say 0, 1, okay, and 1. 1 plus 13 gives you 14 on the E activity. And we still stop and then take a look at C, and we're like, oh, yeah, no. 1 plus 6 is 7. That's far less than 14. 14 is the biggest number. We have 11, 12, 14, and 7. We're looking for the longest total duration. So that's why H has 14. Now we can continue on. 14 plus 4 gives us 18. So the critical path, if they say, what's the critical path? 11, 12, 18, and 14, obviously you're going to choose the biggest number. If they just show you letters, A, B, F, and H, A, D, G, and H, and so on, you would choose the answer that said A, E, and H. Okay? But that's as hard as it's going to be. All right? Any questions on that? Any questions? And I know it's one of those things where you're looking at the answer and you're like, oh, I'm looking at the answer. That makes perfect sense. But it's one of those things where I would definitely maybe use the PowerPoint, the one prior, this one that's blank, that doesn't have the answers, and maybe just change the durations in there and see what you come up with. Use it as kind of a template for practice. The other question that I had come in was, what's the difference between critical path and critical chain? Okay, so critical chain accommodates limited resources on the critical path. So let's just assume we've done critical path analysis and we've determined that the critical path is 18. And then we look at the resources that we currently have available for activities A, E, and H and realize that somewhere in here, Jim's on vacation. Because we look at the resource calendar and we're like, oh, Jim is not there, and there is no float time on the critical path. There's no time for slacking off. Like literally, he needs to start activity day 14, or we're going to, create problems with our schedule. So because gym is now considered a limited resource, okay, gym's now considered a limited resource, we basically have to add time to the critical path. So, hold on here. We'll just call this buffer time, which sounds like way more fun than it actually is. Buffer time. Okay? Which, let's say, Jim has 7 days for vacation. All right, Jim's got 7 days with vacation. We got to add buffer time. We got to add 7 days to, the actual critical path. So if we're just working with days here, what does that do to the critical path? What does that do? Does that still make it 18? What would the critical path be now if we employed critical chain? Just doing simple math. It's 18 now, but we need to add 7 days using critical, increase by 7. Exactly. 25, 25, 25. Right. So critical chain is adding buffer time to the critical path in order to accommodate limited resources. That's all it is. It will extend your critical path, but what are you going to do? You're going to go to your sponsor and go, yeah, we'll have it done in 18 days, knowing full well that Jim's on vacation and that there's no way you can do it in 18 days.